for now. Perfect. So let me show you my screen for 1 second. You see my white screen?
Yeah.
Perfect. Okay, guys. So what we are going to be doing today is loops in general, okay? So what we remember what we have done is already the if, so you have conditions, you have some text here. Then if we want to have more conditions, we have an else if, another condition. And then we have text to what things you want to do. Then finally else and end. Okay, so we have started working with this stuff, with the if loops. We're gonna do a bunch of them also now. The second loop that is really important is something that is called the for loop. Okay, the for loop has the following characteristics. So you do for, you initialize one variable, for example, you can say, from I equal 1, sorry, this is equal 1 to 10. You ask the program to do something, and once it finishes, it simply closes at end. Got it? So what it will do is simply read, let's do something here. Perhaps we can do a very simple example. Let's say for x position I equals I. So what I'm doing here is what, guys? So when we start the loop, I is going to take the first value. So when I equals 1, x position 1 is going to be equal to 1, correct? It continues. I now equals 2. X position 2 is going to be equal to 2, etc. And MATLAB is going to do this until when? Until we reach the upper value. So this will do up to x10 equals 10. So at the end of the day, my x variable is going to be simply 1, 2, up to 10. Make sense to you? So these are the ways the for loop, the way the for loop works. Make sense?
Yes.
Okay. So can you do the following? Okay. Let's create. I want you guys to do the following. I want you to go. Okay, implement this model here. Do a function. Create a function. Okay, let's call it function. I know. My loops. Something like that. And then in this function, what I want is I want you to create a x, something like that, that goes from 1 to 10 using for loops. Okay. Imagine that we have a matrix A. I want you to find A prime using loops, using for loops also. Okay, let's start with these two. Let's say 2 or 3 minutes, guys. Let me pause the video. How are you doing, guys?
I finished. Good. Yeah.
Great. Okay, so let's do, what is my MATLAB? Okay, so we can create a new file, and we can call this, I think, function mileage 2025. And let's save this one here.
Should we be seeing MATLAB right now or still
Oh no, wait. No, MATLAB. Do you see now?
Okay. Yeah.
Okay, perfect. So my loops, remember guys, I always suggest you to do this stuff. I will not write anything, but try always to write this program, describe what the program does, okay? This program, blah, blah, blah. Okay, so now what we can do is, so what we want first is to create X that goes from 1 to 10, correct? So what we said there, we have done this already. For I equals 1 to 10, what I want is X position I equals I, and I simply do end. Correct, guys?
Yeah.
Okay, so this is going to be, I will use this example, very simple example, to show you storage options. Okay, this example is going to be very, very easy, but storage options means the following, guys. Here, when you have this for loop, for example, you don't need to initiate the variable X. The variable X is initiated once X goes to I. Okay. However, there are some instances in which you need to start to initiate a variable X. There are ways to initiate variable X. So when we initiate X, one of them can be the following: X equals zeros. If I want this to be 10, 10, 1. Do you remember what this does? When we do zeros, guys? So I have a vector of zeros, correct? 10 rows, 1 column.
Yeah.
Make sense? And then what I can do is I can do the same here. So it will make more sense later, but normally sometimes we want to initiate X in a given value, zeros, for example. We know that the dimension of the matrix. And then what it's going to be doing is X1, the first zero, replaces by 1, etc. Okay, so there is another way of initiating this one here. Okay, there is another way that is very useful. Another way of initiating X, guys, is the following. Let's call this X1 just to distinguish between the other guys. And let's call this X2. One way of also initiating a matrix, guys, is that you do X empty 2. And the way empty works is basically you are creating an empty matrix. And in the empty matrix, you cannot do this. You cannot assign directly the positions. The way you work with this one here is going to be the following. You create the matrix, and then you say, my matrix is X2. What is X2 semicolon? If you want to have a column vector, I. So, do you understand how this works? Basically, I'm starting this one as an empty matrix. Then when I do the loop, the first I equals 1. What it will have is the first X2 is empty. It put an empty close to number 1, takes the number. So the second time, X2 is already one number. Do you agree? It's going to be 1. What it puts below, 2, etc. Makes sense to you guys? These 3 ways of initiating a matrix. And you're going to see, sometimes this is better, sometimes this is better. I prefer this one here. Because sometimes when you do analysis, guys, you don't know exactly the exact dimensions. Okay? And sometimes you cannot assign this correct directly because you have a lot of matrix manipulations. So the best way to do that is this one here. As you're going to see in a minute, guys, the results are going to be exactly the same. But these three ways of initiations are really important. Questions? You can copy if you want to, 1 minute. I want to put my D so I can stop the program. And then we can run. Okay, you can take a look. X is 1 to 10. X1 is 1 to 10. Well, I did it a column vector. And X2 is also a 1 to 10 because I have defined this with semicolons. If I define this with a colon, so it will be a row vector. And the same here, right? If I define my zeros 1, 10, my vector is going to be a row vector.
Can you show X1 again?
Yes.
So basically X1 and X2 are the same, no?
Yeah, are the same because I define them. So remember, how do I define this to be a vector, a row vector? Sorry, a column vector? By here. When you
Yeah.
do zeros 10, 1, you're doing 10 rows, 1 column. And how do you define a column vector here? By the semicolon. So if you want to have a row vector instead of semicolon, because semicolon, remember, it puts the numbers below the other ones. Do you agree? Comma puts the number to the right. You simply change the column by semicolon by the comma. Okay, it's straightforward.
Yeah.
Okay, so now what I want from you guys is try to improve this model for a minute. I want this model to receive inputs, and the inputs are going to be from to. So what I want from you is we're just in model A, okay? I want inputs, so my input is going to be here. So what I want here is my from to, and then return basically x1, x comma x1 and x2. Okay, 2 minutes. Ready, guys? So if I want to do inputs here, what I want is, let's call it start, finish, SNF. I'm just writing SNF. And I want to deliver X x1, and x2. Do you agree? So basically what I need to change now is this I. Now I is going to be S. Sorry, 1 is going to be S and 10 is going to be F. Let's call this, just to keep the original one, let's call this now B1 at the end. Okay. The same here is going to be S to F. S to F. Make sense to you guys? So how do we run this program? Now I need to run this program from my command window. I need to start this program. Okay, let's do this 1 to 10 just to verify that it works. And then simply oh, yeah, in this case, I need to comment out this one here. Let's run this again. And here you go, x2, x1, and x. Okay, let's do a different test. Let's start at 12 and let's finish at 20. Here we go, it works. Everyone? Make sense?
Yes.
Okay, so now let's do another modification. I want your program, okay, we'll continue with this one here. I want your program, guys, to allow for steps. So basically what I mean is the following. Remember, guys, we had from 1 to 10 is exactly as from 1 to increasing by 1 to 10. But now I want this one here also to be optional. So what I want in your program is from, increase by, and 2. So let's call this S, F, I know, let's call this P, something like that. And test your model. So we can test, for example, guys, from 1 increasing by 2 up to 10. Test with these values. Okay, so let's do the first one. We'll just call this B2. You don't need to do this, guys. I'm doing this just for keeping clean these programs. So now what I want is an extra parameter here that is going to be called P, steps. And then what I want from here is very simple, right? It's going to be from S to P because this is a sequence. And that's all it needs to change. Oh, there is a problem here. You're going to see what the problem is. Oh, oopsie. Okay, guys, here comes the tricky part. Not tricky, but you need to pay attention here. Xi, it doesn't, no problem here because it's flexible. The dimension of this is flexible. Do you agree? This one here is also flexible because you initialize a variable as an empty matrix. The problem is this one here. You are not necessarily going to have 10 observations here, correct? So that's the issue with this notation here, for example. Make sense? Let's keep it like that for now, but please pay attention that the zeros limitation is that normally you need to have oopsie, you need to have a way of knowing the number of observations. So for example, if you have 1,000 observations, okay, then you have a benchmark. And if you're going to do row by row and you know that you have 1,000 observations, okay, perhaps you can do that. Got it? But there is issues with this notation, what you're going to see in a minute. Then I said what? Oh yeah, that's it. This is it. So let's try. You're going to see what's going to happen here. I said it's going to be from 1 increasing by 2 to 10. Take a look. What is this one here? What happened with X? Why X is doing this stuff? 1, 0, 3, 0, 5, 0, 7, 0, 9. Wait a second. So this is something. S is increasing. Okay, there is something that I don't like. So let's stop here. So let's run up to here. Oh, no, sorry. I need to run from here. Yeah, the first variable is going to be 1. Do you see, guys? So the second variable is going to be what? It's going to be 3. The third variable is going to be 5, etc. So that's why this is creating this behavior, 1, 0, 3, etc., etc., etc. What can you do in order to just clean and just have the values that are 1, 3, 5, 7, and 9 without the zeros? Use some techniques that we have learned up to now. You can use the relational variables if you want, right? Okay, go ahead. What you can do here, guys. I have this X here. Okay, so let me move a little this one here. Let me move this to here. Here you have your X. I just want, guys, the ones that are not 0. What can you do? To just select the ones that are not 0. Let's try here. Do you remember this one here, guys? The find command. No. Do you remember this one here? You
Can't
remember the define? Oh, sorry. Yeah, I know what's happening. Yep,
Can't-
tell me.
Can't we just use the steps as so x equals x, open bracket, double dots, comma, one.
X equals X brackets. Okay, sorry. Okay,
No, the other bracket, sorry.
parentheses.
Yeah, the parentheses, sorry.
Yeah. Mhm.
One double dots, sorry, double dots, comma, one double dots, two double dots, and like in the terminal to look for,
Like that.
yeah, to look only for the numbers in the
What do you
terminal.
think, guys? Yep.
In the terminal, not inside the for loop.
Oh, of course. Outside the for loop. So we can write a comment here to consider just non-zero. What do you think, guys? Let's take a look to what happens with this part here. We can test that because I'm active here. So what is this one here? Make sense or not? Okay, so that's why,
Yeah.
guys, we have been learning all these tricks because this happens in real data, okay? And we can copy this one here, guys, because that's gonna be the exact problem with this one here, correct? What we can say is x1 equals xi, something like that.
Sorry, for the x1, don't we have to change the size dynamically? The zeros vector at the
Yes. But let's go first with this one here. Because remember the x, my x1 is now a column vector, do you agree? So I need to select the rows. Okay, forget about this for a minute, because that's the tricky part with the zero initiation. Make sense to you guys? Let's try to run this one here and let's see if it works. Where's my metrics? Oh, need to clean this one here. Let me. You see? You know which one is the one that has really the least problems? Indeed, is empty. Do you see? I haven't done anything else with the empty. The empty doesn't require to select the data, etc. No, the empty simply takes the values that we want to create. If we use the the immediate I notation, the xi, we have issues with the zeros. Sorry, yes, because we're jumping position one, position one, position three, position four. But between position one and two, it will create a zero. As soon as it's nothing here, it's going to put a zero. So then we need to do this type of thing or the find. The same happens with the zeros, and the zeros is even worse because we need to determine this number here. Make sense? This one here, you forget it. You simply define this as an empty matrix, and then you just start working, and this will do the work. Make sense to you guys? Okay. Can you now do this one here? Create a new matrix X3. It's going to be exactly the same as the previous one. Not zeros. I prefer to use the empty. Use the empty to initiate the variable. So the only thing that I want, guys, is that position one of your matrix. It doesn't matter where you start or what values it start. I want you to put it 99. That's all. Okay. 2 minutes to do that. It's a new vector x3. Guys, to make it easier for you for now, it's just to make it easier for you guys. Simply use, yeah, we can use the zeros. And then I want you to test this one in your model. It's going to be 1, 1 to 10. Okay. And of course, I want the first position to be 99. 2 minutes.
Sorry, Professor, can you
Yes.
go back to that
The mat-
screen for 1 second?
Yes, of course. MATLAB, MATLAB, MATLAB. Here you go. The code?
No, to the whiteboard.
Oh, to the whiteboard, yes. Whiteboard. Here you go. You see?
Yes,
This,
thank you so much.
this part here. Pleasure.
Yeah.
2 minutes, guys, to do this. Now you need to use if conditions here, okay? You're gonna start nestling if conditions. Okay, 1 more minute, guys. Okay. So let's do this. Where's my let's create x3, guys. And I will initiate this like this, okay? I will copy all this part here. Okay? So I call this x3. And the only thing that with this x3, guys, is what? Is that the first position must be equal to 99, okay? Make sense to you? That's all what we want. So what I need to do here, guys, is an if condition. So basically what I will say is that if I equals 1, I need to do something special. Okay, so let me copy this one here. So what happens when we're talking about the first position, guys? I want this to force, I want to force this to be equal to 99. Correct? Else, well, you continue doing as usual. Business as usual. And then let's move here x3. And I will call this b3. It's just for me, you don't need to do this. And this is not x1, this should be x3. Guys, questions? Do you understand this part here? It says we are nesting loops. My for loop, my if loop, if else loop, and simply works like that. Where is my x3? Oh, sorry, I haven't defined x3 here. Oopsie. And it's not my v loops. x3 goes with v loops b3. Wait a second, my p is 1, right? Oh, my p is 1. So what I'm doing is stuff here. Oh, this one doesn't work for this one here. Well, I can do another condition here just to make this, to fix this one here. Let's do that if p not equal to 1. Okay, we can do this. And we can copy the same in here. Here. And this should be, just to make it more consistent, should be like that, right? And the same here. Uh, Here you go. X2, X3, I replace the value 99. Make sense, guys? Questions? Guys, questions? Make sense?
Yeah, thank you.
Perfect. Can you do the following? Okay, just to complete this one here. Continue with a x3, where I want position, any position. Position 3 must be, I don't know, 88. Okay, in the same x3. Two minutes to do that. Okay, one more minute. Okay, so let's do this very quickly, guys. What I will do is simply change my if condition. Okay, I need to add one additional condition. So if it's one additional condition, I do the else if, and then my condition is if this is equal to 3, something's going to happen. So x3 of I, oops, is going to be equal to 88. Else, we continue as usual. Make sense to you guys? So let's try to run this one here. Here we go. 99, 88, etc. Questions? It's clear? So you know how to use the for, the if, else, etc. So let's do can you open the file that I sent you today, guys, that is called, I think, X transpose. Can you open that? can you take 1 minute, guys, to analyze what this program is doing? It's a very simple, straightforward program, simply to create a transpose. Okay? So what this program does, guys, if we want to do this, we can run one line by line. So it creates a matrix A, creates an empty matrix where it will store the transposed. And then here what we are doing is the following, guys. So remember, where's my matrix? This one here. So remember, what is a transpose? I will do an example, very simple example. So V equals position 1, 1, position 1, 2, position 2, 1, position 2, 2. So B prime equals what? It's going to be position 1, 1, position 2, 1, position 1, 2, and position 2, 2. Right? In terms of positions, guys. Agree with me? So what happens when you do the transpose, guys, is this is clear. 1, 1, of course, they have moved. 2, 2, they have moved. But you can see here the row becomes what? Becomes a column. And this one here, that was the column, now becomes, sorry, this was my column, now becomes my row. So this is my row now. So we are shifting simply the positions. Got it? And that's exactly what MATLAB is doing here. So I'm starting, so I start I equals size of A2. So A2 is the number of columns. And then I do J equals 1 size of A rows. And what we are doing here is that the position of the new matrix IJ is going to be the matrix, the original matrix, but positions J and I. So I'm shifted. What was a row at the beginning now is a column, and a column is a row. Make sense to you guys? If I finish this running, I have my transpose of A, 147, 147, 258, and 369. So we have transposed our matrix, just using for loops. Make sense to you? Allow me 1 minute, guys. I will record this one here. I will save this one here. Okay. So let me clean this one here. Let's open a new one. Can you open, guys? I sent you a file that was named my annuity. take 3 to 4 minutes to analyze the program, check the program, and run the program with the following components. I want a loan of $100,000. My annual interest rate, let's call it 7%. And my number of periods in months, let's say that it's only 6 months or 12 months. Please give me the payment. What is the payment? And payment schedule. Okay, 3, 4 minutes. Please analyze the program, understand the program. Of course, it's completely inefficient because I have used a lot of for and if loops, but helps us to understand how the for and if loops work. Okay, let's say 3, 4 minutes. Two more minutes, guys. One more minute, guys. Okay. So we want 100,000, 7%, 12 months. Let's go and see the program. A very simple, straightforward program, guys, that simply estimates, it calculates the payment, calculates the payment schedule, etc. Okay, this is done with formulas, okay? And this is crucial, guys, because this weekend you're gonna have a portfolio optimization challenge. I will give you the Excel file to you with the formulas, etc., etc., etc. And so basically what you need to do is this portfolio optimization model, you need to import this in MATLAB and create your MATLAB code based on the formulas, etc., that we have in the Excel. Okay, so it's gonna be a kind of a long 2 or 3 hours work for this weekend, just on that. Okay, so what is beautiful about this type of programs, guys, is if you have the formula, you can program the formula, okay? In this case, my monthly interest rate equals 1 plus I to the power 1 over 12, because what I'm receiving is the annual interest rate. So I need to transform this into a monthly interest rate. Then my factor, guys, if you remember, when we have this type of projects, so I have a present value. Then remember, I have a series of equal payments. Let's say periods 1, 2, 3 to n. The payment, so this PMT was equal to PB. The multiplier is 1 plus I to the n times I divided by 1 plus I to the n minus 1. Okay? So this one here is what is called the factor. Of course, the PB is the amount of money you receive. N is the periods, the number of months you're going to pay. And the payment is how much you're going to pay periodically. Got it? So that's it. So this factor that you see in MATLAB is simply this formula. Take a look. 1 plus I, that I call monthly interest rate, to the N, multiplied by I, the monthly interest rate, divided by 1 plus I to the N minus 1. This is my factor. Then if I want to compute my payment, it's simply the principal, the one that goes here, times my factor. That's it. I'm creating my payment schedule as an empty because I don't know how many rows. I prefer to be very flexible in number of rows and columns. So that's why I'm creating the empty matrix. And then what I'm doing is basically doing, okay, I'm going to create my table, okay? For I equal 1 to number of periods, so if I have 12 months, this is going to create 12 rows. The only trick here, guys, is that when I equals 1, the principal is going to be equal to the original principal. Okay? These formulas here are the same. Interest auxiliary, I'm calling what is my interest I will pay, is always my principal that I owe to a bank multiplied by the monthly interest rate. And my capital is always going to be equal to the payment minus my interest. Okay? For the first one is the only one that I need to be careful about mentioning the principal here. And every data is moved like that. Once I computed this one here, I store this value in my matrix, empty matrix that I call payment schedule. I put I, then the principal, I is going to be my 1 to 12. My principal, my capital, my interests. Okay. Now remember that I need to add my how do you call it? My payment, but my payment is a single number. Got it? This one here is a single number. So that's why I need to do a rep mat. So what I've done is payment schedule final equals payment schedule. So I copy this matrix into here. And then I simply join to it rep mat payment end periods, comma 1. So I'm replying I'm replicating the payment 12 periods, and that's all. Okay, so we can run this program. Any questions, guys? Okay, for now, don't worry about the way these formulas work. Okay, just assume that you know the formulas. Got it? So let's take a look. This one here. So I want a principal of $100,000. I want a 0.07 annual interest rate. And I want 12 months. Here you go. We start with $100,000. My payments are always the same, 8642.77. Remember, guys, that what you compute first is the interest. So this interest, guys, if you do, is equal to $10,000 that multiplies the interest rate. So it's basically, if you multiply $100,000 times, I call it, what is the monthly interest rate? Times this number. You see, 565.41, this number. And then the capital payment is simply the payment minus the interest payment, give me this one here. Now, what is the amount of money you owe to in the next period? Is this $100,000 minus this money that you are paying in this period. So this is what is left. Now, how do you verify that this payment structure is correct? When the principal at the end of the last period is exactly the same as the capital that you're going to be paying. So these two must be equal to verify that indeed your program has been written correctly. Make sense to everyone?
Yes.
Perfect. Okay, let's do one more. I send you a file that is called my NPV, my net present value. Can you open that file, please? You have 5 minutes to analyze that. It's called, the file is called my NPV. Let's say 5 minutes to analyze. Oh, let me give you an insight of how this works, okay? So I will use the numbers that we have in the matrix. So basically, guys, my NPV, as I mentioned to you before, I have an investment, $1,000. And then let's say in 1 year, I will receive $750. And in 2 years, I will receive $2,500. Okay, so this is the cash flow. So how do I compute my NPV, guys? My NPV is simply, I need to move everything from the future to the present. That's why it's called net present value, net present value. So what I need to do is, okay, the first one, as soon as this is going down, is a negative minus 1,000. Plus this 750, guys, is updated, is discounted 1 period. 750, 1 plus I. This I is called opportunity cost. Okay, and plus the 2,500 updated how many periods? 1 and 2. So that's why it's 1 plus I to the power 2. Okay, so you have this data, you have this cash flow, and then you can compute your net present value. So remember, guys, that the rule from a net present value is if the net present value is larger than 0, then do project. This is the net present value. Now, if you want to think about the net future value, what you need to do is you need to move everything to the future. So if I move this into the future, it's going to be my 750 times 1 plus I. So I have a value here. I can sum these two values. So I think the opportunity cost is 0.10 according to the program. So 750 times 1.1 is going to be equal to 825. I sum these two numbers plus 2,500. This is equal to 3,325. Now, if I move the $1,000 to the future, I need to multiply this times 1.1 squared. So I have 1,000 times 1.1 squared. This is equal to 1,210. If I subtract this value minus this value, 3,325, so I obtain a value that is equal to 2,115. This one here is what is called my net future value. Okay, my condition with the net future value is the same. If the net future value is larger than 0, then do the project. Okay. Of course, guys, like I mentioned a couple of classes ago, these two cash flows are equivalent. What is the meaning of equivalent? This is net future value. So what I can do is 2,115 divided by 1.1 squared. So what I'm doing, this future value, and moving this to the present, I must obtain, if we have done this correctly, I don't know what is the net present value, but I should obtain here, let's do this with the numbers. This is 1,000 plus 700 divided by 1.1 plus 2,500 divided by 1.1 squared. So this is what? This is, give me 1 second, 1,000 plus 750 divided by 1.1 plus 2,500 divided by 1.1 squared. I obtain 1747.93. So I should obtain here 1747.93. Let me check. 2,115 divided by 1.1 squared. Yes, correct. Okay. So that's why they're called equivalent. Okay. So that's what the program is doing. So now you have 5 minutes, guys, to analyze your my function NPV, please. So now read this code. You understand what you are doing. So try to read the code 5 minutes, and then we simply run the program.
2 more minutes, guys. And run, and you can simply go line by line and test. Remember, you have a D, so you can basically do line by line. Okay, 1 more minute and then we do it. This was part of the assignment number 4. I think that you need to modify and improve this program, right? Okay, so let's do this very simple. I have my X, I have my opportunity cost, I have my size of X, M and N, number of rows and columns. And then what I'm saying is that if M larger than 1 or N larger than 1, I have an input vector. I just need a line like this, just for showing you the error messages that we have done in the past. My index is going to be the length of X, so it's going to provide me 3 in this case. I'm creating an empty matrix. And then what I do is from I equal to 3 in this case, I think N is 3, yes. What I will do is if I equals 1, the first value is going to be exactly the same as the value that I entered here. You see? Then I simply join aux, simply put the value here. Then for when I is 2, it's going to be the X position I, discounted at 1 plus the opportunity cost to the I minus 1, because I is 2. Guys, remember when I told you here, the first discounting is to the power 1. So that's why if I is 2, I need to do I minus 1. So in order to obtain the 1. And then when I is 3, it's going to be X position 3. That's correct. 1 plus 3 minus 1 is 2. And then I have my matrix. Then I have all my values. And what I do at the end is simply sum. Make sense to everyone? Make sense? And here I have my NFD, 1747.93, exactly the number that I got in here.
Questions? Ah. Okay, guys, questions? Let's go to the next type of loops that is called the while loop. While loop. And the while loop works in the following form, guys. First, we need to initialize a variable. Let's say equals I equals 1. And then what I will do, take a look to what happens with while, is while I is smaller than a given number, let's say smaller or equal than 10, do something. Okay, I will do the same. X of I equals I. Okay, so what I'm just creating is when I equals 1, position of X equal 1 is I. But what I need to do here, guys, is I need to modify my index. So I need to say my new index now is I plus 1. You see? So when I is 1, the next I is going to be 1 plus 1 is 2. And then you simply close this one here. So it will run up to the position when I is 10. It's going to be X position 10 equals 10. I equals 10 plus 1, 11. Goes out and asks the question again. Is I smaller or equal than 10? No, finish. Boom, goes here. Make sense? Makes sense to you? Can you create this for loop, this while loop, guys, as a function? So let's call this function, let's call this as a function my while. Okay, 2 minutes to do that. One minute, guys. Okay. So let's take a look to what happens here. So I wrote a function that is called my while. I equals 1. I am starting my indicator. And then this program is going to run the while loop until I satisfy this condition, I less or equal than 10. Okay, what it will do is x of 1 equals 1, I goes to 2, 2 is smaller than 10, yes, x2, etc., etc., etc. So let's take a look to what happens here. So let's simply run this program. And I have my x here. You see? 1, 2, 3, 4, 5, 6, 7, etc. Questions? It's clear, guys?
Yes.
Perfect. Okay, so now what I want from you guys is the following. I want you to modify this while program, and let's call it, you can call it whatever you want, but what I want from you is you need to enter the arguments are going to be n and increment. So this one here is the maximum number. I want this to be 10, for example, and I want this to be 2 for testing. And what I want is a program, instead of doing from 1 to 10, for example, I want this to go from 1, 3, 5, 7, 9, for example. This example should create this one here. Okay? Using while loops. Let's say, guys, 3 to 4 minutes. So just modify this program here. What I want is your program to accept 2 arguments, and this returns x. N is going to be the maximum number that I want to run. My increment is by how much I want. And if you put 10 and 2, I want you to be able to create 1, 3, 5, 7, and 9. Okay, using the while loops. Let's say 3 minutes. One more minute, guys. Okay, so let me show you what I've done here. So I want n and the increment. X is going to be my output. N is going to be the maximum value. What I've done is I have created two indexes. Okay, one is for the increment. Oh, this is wrong. One is for the increment, and the other one is going to be for a position. So in this case, J is going to be the position of a matrix, and I is going to be the increment that I'm looking for. Okay, so remember I want to create 1, 3, 5, 7, and 9. Okay, so what I do is while I is smaller or equal than n, so imagine n is 10, I starts at 1. So is 1 smaller than 10? Yes. Take a look here, guys. J is the position. I is simply the number. So what I do is x of j, so x of 1 is going to take the value of 1. I is going to increment not by 1, but by the increment. You see, I equals I plus increment. So if it's 2, the next I is going to be 3. The one that is position, it increases by 1. So my position now is position 2. Now I ask, is 3 smaller than 10? Yes. X position 2 is going to be 3. The new increment is going to be 5, etc., etc., etc. And this should work. So how do we run this program? Remember, when you have inputs and outputs, so we need to run this from the worksheet. Now, command window. And I said I want this to be 10 and the increment to be equal to 2. Here you go. Okay. Make sense? Guys, clear?
Yeah.
Okay, now guys, let's go. I send you a file. Can you open the file that I sent you? I send you one file. What is this one here? I think the file is called, what's the name of the file? Oh yeah, temps original. Temps. Temps original. Yep. Can you open your Excel file, guys? So what I have here, guys, is simple data set, very small. Temperatures of 3 cities during the last 30 days, I think, or something like that. Yes, during the last 31 days. So temperature of city 1, city 2, and city 3. Very simple data set. Okay. So what we're going to start working now, guys, is simply trying to upload the data into your programs. Okay. So the first thing that we need to do is I need to check where I have my data. You need to do the same, guys. Check where I have my data. And I will go to MATLAB. And the MATLAB command, I will take this num equals, the MATLAB command is xls read. Then I need to do between these ones here, program MATLAB program, and the file is temps original.xlsx, something like that. So I can minimize this one here. Let me copy this one for 1 second. Let me clean this one here. Yeah. So by default, guys, when you have a single variable here, XLS read is only going to read the the numbers, not the labels. Okay, can you check that? Are you able to open your file? The MATLAB command is XLS read. You simply give the address up to here, and then the name of the file. And if you just write one argument, okay, the name is indifferent. One argument, what it will take is simply consider the values, the numbers. Now, if you want to consider, okay, copy this one here, and then we can go into more complete way of uploading data. Now, I will copy exactly the same, but in this case, what I will do is I want to upload also the labels. So the first one is going to be the numerical, and the second one is going to be the labels. Okay. Remember, these num and labs are simple names, guys. It's nothing. It's simple. You can call it X, Y, A, B, whatever you want. They are simply names. You can see the labs has now the CT, CT1, CT2, CT3. So, and the nums, the data. Okay, let me close this one here. Here's the MATLAB. I will call num1. And I will do something here. It's very interesting. Sometimes it's useful. When you have a small data sets, works nicely. Hopefully this version does that. So what I have done is the same. I just call a different number. XLS read, the address, the name of the file, and then comma -1. Are you with me, guys? Because we need to do this together. Okay, so if I do this, okay, so I need what MATLAB does is open your Excel, and then I need to select the data that I want. So for example, I want to select this part here. And once you have done that, simply click OK. And then what MATLAB does is, have you seen that? It selects only the data that you have selected with your mouse. So this is the what -1 does, allows you to dynamically select the data from your file. Okay, this is useful. I have used this a couple of times only for small data sets and to show when I'm doing a presentation for a client. I simply, I just want a specific range of data. I simply collect the data and move it into MATLAB, and then I can do analysis in here very quickly. Okay, there is another way of doing the same stuff, is that instead of using the -1, so what I can tell MATLAB is, okay, I want from A2, I don't know, to C10. Okay, so this is another way of telling MATLAB what part of my data set I'm looking for. The most complete way of calling in MATLAB is you give the address, the name. You also can give, I think it's called sheet 1. Let me check. Let me open. Yeah, you can give it also the name of the tab. Sheet 1, comma. So it says the following: from this address, this file, open this sheet, this tab here, and select from this tab this data. Okay, and this is useful because in Excel we used to have a lot of tabs, and then we just want to select the data from a specific tab. So this is the way we're going to get this one here. In this case, I only have one tab. So what's the name of my file? Give me 1 second. I need to be sure. Up here. Oh, sorry. Should go like that then. Yeah. Okay, so this is the command XLS read. And now let's go, let's try to now save something in Excel. Okay, so let's create X that can be, I don't know, the common 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, my common X. And I just want to save this one here. Let me copy this one here. And the MATLAB command is going to be XLS write. I don't need this part here. I need to have the location. I need to give a name to this one here. I don't know how we can call it. So let's write example class 6 2025, for example. And what I want to save X. I just want to save X. That's what I want to do. Okay, so it is what I want to write. X is XLS write, address, name of the file, and what you want to save in the file. Okay, so let's find, for example, class, so MATLAB files. Let me do the date modified. here we go, example class 2025. And here I have my X. Okay, later I will show you how to introduce the labels, etc., etc., etc. But that's the easy way to write something, guys. Okay. Let's close this one here, and let's create another file here that is going to be called A equals, I don't know, whatever, 10, 20, 30. Okay, so I have my matrix A, and what I will do is I will write this one here in the same matrix. Okay, but I want to save A, what I want to save is A, and in the second tab. Okay, this is a generic second tab. So if we do this, take a look to what happens. So what it has done is has opened this file, has located the tab number 2, and is saving everything that was in A, this one here. So let's take a look again. Where is Excel? Yeah, so let's go and open this one. You see, guys, sheet number 2, I have my values of A. So let's create something more. Let's go to MATLAB. So now let's create another Y, for example, that is going to be equal to a large number, okay? 1 to 100, and let's say 10 to 109. Okay, this is going to be Y. I don't want to print everything because it's going to be a large matrix. Let's take a look to the size of Y. It's 2 rows, 100 columns. Okay, I will not record everything. What I can do, guys, is I will do the save. Okay, from here I want to save Y. Okay, and I want to create a new tab. Okay, the tab, let's say is going to be, sorry, it's going to be example 3. These are names. And what I want is simply to save in C2 to F4 to, F3. So what I'm doing here is the following. Okay, open my file. You're gonna save Y, so this matrix here. But in a tab that is gonna be called X3. Is a name, guys, it's simply a name. And I just want to record in this range from C2 to F3. Whatever fits from this big matrix, you just put it there. That's all what we want. Okay, so let me be sure that that matrix is closed. I need to close this one, otherwise it's going to collapse. Then I can run this one. Let's take a look. File. Here we go. It has created, you see the label, example 3, EX3, and has saved the data only that fits this part here. So the matrix started, remember, it was 1 to 100 and 10 to 109. So it saved only up to here and only up to here because that's what I told him. C2 to F3. That's all what I was requesting to save. Okay, guys? Questions? Questions? Okay, I send you a file, I think, then the file name is, give me 1 second. The file name should be, close this one here. Yeah, the file name should be, what was the name? I think it was temps. no lab txt. Oh yeah. This is also important. Oh, what I have done. No. Open temps. What's the name of this file? I think it was temps example. Oh yeah, this one here. You have this file here, right, guys? Can you verify that I send you this file? Can you verify this file, guys? Temps example text 2024.
Yes.
Okay, perfect. Can you open that file? And then this is also important, guys, because sometimes we have a different file that is txt, CSV file. It's not an Excel file. So when you have a text file or CSV file, guys, the way you load this into MATLAB is with the word load. Okay, then you write the address and the file. Now, what is interesting, guys, when you work with a TXT file for MATLAB or R, it doesn't recognize letters. That doesn't recognize characters except numbers. Okay, so you just need to be very careful with your temps lab, no lab. Basically, your file needs to be saved as without let me find this one here. Just you to take a look to how the temps. Here we go. So let me open this by Notepad. You see, when it's a TXT file, in order to preserve the distances and everything, it doesn't have the labels. Okay. Later I will show you how to solve that issue. But for now, let's assume that we have that. So I will load the data. Load is for TXT CSV files. I'm counting the number of observations. And I'm doing D is a sequence. Okay. Can you take 3 minutes to analyze this one here, guys, and then we start talking about this? Okay, 3 minutes. Give me 1 minute. Yes, guys. Understand what the program is doing. You know what it's doing already. Please go ahead. Okay. Do you see my MATLAB? Guys, do you see MATLAB?
Yeah.
Okay. So what I'm doing is I'm loading. I will do a stop here. So let's run this one. I have number of observations. I have 31 times 3. So D is going to be simply 1 to 31. So a sequence. And then what I will do is I will plot D with temps. I will put the label titles. I will create another figure. I will create a histogram with a label and labels only. So let's do this up to here. So I have my histogram and I should have my line graph. So these are the temperatures of the 3 cities in Celsius, day of the month for the 3 cities. Then you can do more things, guys. You can save it, you can modify it, you can do whatever you want. You know how to do that. And then I simply compute what is the mean of the temperatures, what is standard deviation of the temperature, what is the medians of the temperatures, and give the correlation coefficient of temperatures. And then what I do is I create a new matrix that simply has all this information, the means, the standard deviation, the medians, all transposed just to fit the table. I have my correlations. No, just what is this one here? Position 1, 2, position 1, 3, and position 2, 3. So the correlation is not equal. Then I'm just doing here, find A. A is going to be the temperatures larger than 10. B is going to be the sum of temperatures between 5 and 15. And C is going to be simply the temperatures between 5 and 15. That's it. It's just for practicing. So we can take a look to what happens. And here I have the means, the standard deviations. The matrix has the means first, the standard deviations, the medians, and the correlations of specific correlations. And that's all. Make sense to you? Okay, now let's go to another one that is a little more complex. So this one here, guys, is using load because we are using a TXT file or a CSV file. Okay. Now, can you open, please, the next file that is called temps example 225, I think. Let me check. Do you have this file? Temps example 225, this one here. You have this file? Can you check that? Yeah. Can you open this file? Do you have this file, guys? Temps example 2025. Do you have that?
Yeah.
Okay. Can you take 3 minutes to analyze the file? Then you go with me. Here, what we are doing is we're opening with an if condition. We're doing basically the same, but we have this XLS right. Can you take a look to that, please? Let's say 3 minutes. It's very simple. The next one is the more complex one. 3 minutes, guys. One minute, guys. Okay. So let me continue with this one here. Look, guys, normally why I do this one if Eric equals 0. So normally at the time I was not moving my laptop. I travel, so I put this in a cloud. And I have 2 or 3 different computers and the different addresses. So what I said is, okay, if I write 0 here, it will go to my home computer. This is my laptop actually now. You see, this is where I have my temps original file that we saw before. Otherwise, you can put any other address, it's just to show you. Then I do the same. I do the plots, I do the figure, I do the histogram, I do descriptive statistics. I don't care about this stuff, blah, blah, blah. What I care is about this part here. So let's run this up to here. Okay, so let's close. Yeah, this was. And then, guys, that the way you write this one here, so I want to write all my results. I want to write in this address and this file, first, the daily change. This is my daily change. Then I want to write, the daily change is going to go into the first page. The correlation also, this correlation metric is going to go in tab number 2, this one here, sheet number 2. The average temperature is going to be in a new tab that the name is going to be mean. And the average temperature partial, I don't know what is PRT, is going to go into a new tab that is called mean part. Got it? So if we run this one here, let's take a look to the file. Is temps here. Let's open the file. Oh, sorry. This is the one that I created. Take a look. So in the first page, I have my temperature changes. In the second one, I have my correlation structure. You see, it doesn't change when I write 2. It simply uses the same Excel sheet number 2. But I named my tab to be equal to mean. And I want it to be the mean part. I don't know where is that, but this is this. Makes sense to you guys? So let me go back to let's stop this one here. And this is the way by which you save your results. You call your results in this way, XLSRead. Remember, the first one represents numbers, and the second one, the headers, the labels. And when you save, you simply put XLSWrite. Okay, questions. So now we can go to the last one. And with this one here, guys, you can create basically, next class we'll do optimization, and then you're going to be able to create whatever you want. Okay. Can you open this file, please, guys? It's called temps example save 2023. Invest 3 minutes to try to understand what this program is doing, and I will explain you a lot of things here. Okay. This is a very beautiful project. It's very simple, but it is very useful. 3 to 4 minutes, guys, to understand. 1 minute, guys. Okay, guys, so let me show my screen and let's go in detail with this program, okay? This program is one of the most dynamic programs. It's very simple, like I told you, but really can allow you to create programs that are dynamic in terms of addresses, in terms of project name, etc. Okay, so how this works? I'm creating a variable that is called directory that will contain the address of my files. So I don't need to be copying this file anymore. I don't need to do all this long address. I will simply call directory. Also, the project name is this one here. I don't need to be copying this many times. Right? And here, this is what is extremely useful, guys. Please, attention here. So let me tell you what I'm doing here. U is a simple text variable. Okay, I'm simply writing this one here. Take a look to what happens when I do this in the. Let me clean this one here. Take a look to what I'm doing. I'm creating this. Remember when we call up when in the last program I called this one. I created this one here. Temps. What I'm doing is I'm writing this one here in a way of a text. You see, take a look. Temps and her text, well, labs in this case, XLS read. Then, without apostrophe, I want this directory name that I define here to fit here. And also the project name to fit in here. You see, XLSB, well, and take a look to sheet number 1. So take a look to, if I do this, oh, I need to run up to here. Yeah, now should recognize that. Take a look, guys. What I have done is I simply U simply means this is what I want to write. Temps labs XLS read all my address and the file that I have. And look in sheet number 1. That's all. Okay. Now, how do you make this is text? So MATLAB, for MATLAB, text is text. MATLAB doesn't react, doesn't do anything. The command that makes MATLAB to do something is this one here. Evaluate. Eval. So now MATLAB is going to tell, when I use this command here, it's going to say, okay, now execute what I have written here. And what I have written here is basically, guys, what we wrote before. This one here. Okay, so let's do this. You see, now I have temps and I have labs somewhere. Whose? I have temps and I have labs. Now, I do a condition here. Normally I do these type of things. Saving if save equals 1. So this implies I will save my results. Otherwise, normally when I do testing, I don't want to be saving results that I will not use. So I simply write a 0 here. Okay. So you can see all the what is this one here? Yeah, yes. So basically what I'm doing here is number of observations. D is an index. What I will do is I'm summing columns. Okay, and I will take the average of the columns. And let's stop here. You can understand this. It's very simple. I just created whatever. to show you. So this is what I'm doing is I'm summing all the columns. So sum temps that has 3 columns, sum all the columns. These 2 here implies sum the columns. Now average column, what I do is I'm taking the mean of temps 2 of the columns. Here you go. And then what I want to do now is simply to start saving. So the program works in this way. I have save equal 1. Yes, I have saving equals 1. What I will define, guys, is the maximum observations that is simply equal to the size of temps. Why temps has so many variables here? Well, in any case, size of temps 1. So how many rows? 31. So the maximum observations is going to be 31. Okay, so this is the way in which you create, guys, the names. I create a column name. One is going to be the sum. This is you curly brackets up and down. The text between the semicolons, between the apostrophes, sum and averages. And then I simply start writing. U is going to be XLSWrite, directory, project name, a column name. So I want to introduce this one here, column name. I will put this in sheet number 1, and I will start this in position D1. So take a look. So my sum and average is going to appear in position D1. Okay? Then I run this one here, and I will simply create the text. So let me check this one here. Where's my file? Temp save 2023. So let me go. Let's go to temp save 2021. Temps save. I think this is the one. Yes. So this is already created. So what I have done here, I said in D1, copy the labels. So this is what we have in here. Copy the column name that is equal to sum and average in page number 1, sheet number 1, and location D1. So what MATLAB is going to do is going to create these 2 names in here. Sum and average starts in D1, and save this one here. So this is the first part of the saving part. Now, the second part, what we are saying is, okay, now save in the same directory, same project name. What is that? The sum call. Okay. Sum call is this one here. It's basically 31 times 1. And start at D2, but you need to tell up to where. Okay, so you're going to start at D2, and this is the thing that tells MATLAB num to a string max ops plus 1. So basically, remember, this is a string, so I cannot use a number here. This is okay because it's a string, it's a letter, character, but this max ops is a number. You can see max ops is defined in here, it's a number. So what you need to do, guys, is you need to transform this into a number. Into a string. So that the command is num to a string max ops, that is 31 plus 1. Why? Because I'm starting, why 32? Because I'm starting at D2, and I want to go to position 32, D32. Take a look to here. I will start at D2, and I want my data to fit up to D32, my sums. Okay, so the sum is simply the sum of these ones. That's correct? Yeah, etc. So let me go here. And this is D2. And then finally, I want to add a last column that is going to contain my average. So I do the directory, the name. This is the data average column, this one. Put in sheet number 1. Start on position E2 up to where? E32. This is what I say. And then this will create this last column here. Make sense to you? Questions up to now? I will run up to here. I need to close this file. Close this one. This one. Okay, so I will run. And it has created what I told you already. I created this already, so don't need to do this again. Now I do descriptive statistics. What I want is simply to show you how this works, okay? So I can run this one here. And then what I'm doing here is I just start typing daily change, correlational, average temperature. Save this in a daily change. The tab is going to be daily change named. This is sheet number 3, and this is average temperature. Okay. And then you have, okay, so let's do the first one here. Daily change 3. Let me open the file. Let me open the Excel file here. So basically what I'm creating is sheet number 3, a daily change, page number 3, the correlations, average temperature, and that's all. That's all what I have done up to this point. Then what I will do is I will stop here. Okay, let me close this again. Let me run this again. Then what I will do, guys, is I will create a table. Okay, very simple. The temperature, original temperature, the means, the standard deviations, the median, the correlation matrix. And then I create a matrix export. This is a name, includes the means, the standard deviations, the medians, and part of the correlations. Again, I want to save. I need to know how many rows I need to use. So normally you do the size of the matrix that is going to be exported. In this case, my matrix that is going to be exported is mat_export, exp. Take the number of rows. Then the column names are going to be the mean, the standard deviation, the median, and the correlation. So these are names. And also I can add column name. I can add row names. Okay. So row names, I call them C1, C2, C3, just any names. And then I start saving. Okay, in the directory project name, save the column names and position B1 to E1. Okay, so let's open this so we can take a look to what I'm doing here. B1 to E1, you see? I'm telling MATLAB to put here the labels that I'm writing here. Call name. Then I'm telling MATLAB, hey MATLAB, go to position 2 in the same table and save the row names. So what MATLAB is doing is creating C1, C2, and C3. It starts at A2 and finishes at A4. This one here. And then finally, just put the table. That is called matexp, this one here. And it starts in B1 up to E, and you need to give the final position, B2E. Maximum is 3 times 1. 3 plus 1 is 4. And I will create, basically, goes here, B2 to E4. And I will save this data here. And that's all. So let me stop here. And let me close the Excel to allow you to run this one. And let's go. And here we go. That's it. So guys, from this file, you need to understand how this works. It's extremely useful. You don't need to be saving every time the directory, the project name. And it's extremely, extremely flexible, guys, in order to, when you have these huge loops and you want to do simulations, you know, I used to run simulations that lasted at least 2 months of simulations. So you need to be able to change the names, for example, that the project names can be changing. Okay, the directory, you keep it, but project name can be 1, 2, 3, 4, 5, 6, 7, whatever you want. So this is an automatic way of running programs, guys. Uploading and running and saving data. Make sense? So you have this file, you need to analyze this file, and you need to use this file in terms of this type of commands, please. Okay? Okay, guys, questions? So today I will send you your, I need to send you the 5th assignment. Okay, so the fifth
You sent
assignment,
us
guys,
homework
yes,
5.
yes, homework 5. Okay. Oh, I will send you homework 5 today. Okay.
I think you did.
Oh, I did it already. Oh, yes, I did it. Of course, I did it
Yeah.
already in the morning. Thank you. Okay, so what is important from number 5? Remember, it's going to be solved also during the weekend. What I suggest you guys is to start moving, because on Wednesday Wednesday is a 1-hour class. Then you have 3 hours video that I need to give it to you, and then for the weekend you are going to have it's one large project, 1.5 large projects that you need to be able to run and program and everything. I will explain this on Wednesday. Okay, so if you can be moving with homework number 5, please, it's going to be very helpful for you. Okay, guys.
Professor, real quick,
Yes.
did
Yeah,
you
yeah.
say that class on Wednesday was only going to be an hour long? Did I just?
Yes.
Okay.
It's going to be from 6 to 7 because I need to do one specific topic. Then I need to explain you what you need to do for the weekend. That is basically going through the model in Excel. I will give you one Excel file that is it has 4 pages, but it has full formulas and graphs and everything. So this is one of the largest assignments you're going to have. It's not the largest. The largest is going to be for next week. But basically, you're going to create. It's called a CAPM model. Okay, so you're going to create your own OLS model. You're going to create your own model, your beta, estimate betas, etc. I will explain you this tomorrow. No, sorry, not tomorrow, Wednesday.
Gotcha. Thank you so much.
My pleasure, Anne. Okay, guys, so we stop here. Yes, go ahead, please. Questions?
I was just saying thank you.
Okay, Simon, thank you very much. See you guys. Have a good night.
Yeah, good
Take
night.
care. Good night. Bye-bye.